So my name is Nandini Duraisamy. I'm the Managing Director and Partner in Quadron Cybersecurity Services, Middle East. Now, the agenda looks like this. We are going to talk a little bit about what is and why an organization needs Zero Trust. And then how do we define the protect surface for your organization? Once you identify that, how do you map the transaction flows? And what are the architectural principles surrounded it? How do you design? And how do you implement it? And if we still have some time, we can take a couple of questions. Okay, so what is Zero Trust? Okay, Zero Trust is not something that you can easily implement with a new technology. It's not like a plug and play. You bring an appliance and put it in a data center in the middle, and then it's going to be giving you a Zero Trust everywhere. It's not a point product or a service that you just buy. So Zero Trust, you should assume that it's like a model and a mindset. It's a strategy, it's a concept, it's not a compliance regulation, okay? Zero Trust basically assumes that every user, an individual or a host or a device or any services that are attempting to access any resources cannot be implicitly trusted. And hence, every time when any of these access has been attempted, it's been validated at every stage of the digital interaction, okay? So in simple word, never trust, always verify. So this is what Zero Trust as a concept, as a strategy, as a definition that NIST also talks about it. Now, knowing that, let's see how the traditional IT network works. So you have a perimeter, and anything outside the perimeter is not authorized to get into the network unless you have proper identification, authorization, and authentication. So once you have it, once you're in the network, in a traditional network, you would have much more ease access to move across laterally within your environment. But when it comes to the Zero Trust architecture, whether you're inside the perimeter or outside the perimeter, you will not have ease of access to anything until and unless you are verified at each stage of your attempt to access anything. Having said that, let's see what the paradigm about the Zero Trust as such. So when you talk about Zero Trust, there are three things which you need to consider. One is about what kind of environment your organization is in, and what is the architecture that comprises the Zero Trust, and what is the concept of Zero Trust, okay? So when we talk about, each one of you can actually relate to the environment where you belong to. So what do we mean by enterprise with satellite facilities? So this refers to a large organization. It has its main office or a data center, and it has multiple remote satellite locations. So they need to ensure secure and efficient connectivity and data sharing between the central site and these satellite facilities. It's a typical data center and multiple offices. And now you have the multi-cloud and cloud-to-cloud enterprise when people are moving from the on-prem to cloud environment. So this involves a business that uses multiple cloud service providers or has a complex cloud architecture. So managing data, applications, accesses, and security across these diverse cloud environments is a key challenge. So Zero Trust can address that. Now, enterprise with contracted service and a non-employee access. So this could be the small and medium business. So what does that mean is like an enterprise relies on external vendors or contractors for specific services, or has someone as a non-employee personnel who need access time to time to its systems. So ensuring the secure access and data protection for these external parties is very crucial. Collaboration across enterprise boundaries. So this is basically the data sharing between an organization and a third-party vendors, external partners, suppliers, or clients. Now, how do you make sure that the collaboration is secure between these entities? And the last is the enterprise with the public or customer-facing services. So it's like an e-commerce portal. So all the any enterprise that provides services or applications directly to the public or customers over the internet. So ensuring because the internet is like never secure. So ensuring the security and availability of these services while still protecting the user data would be your primary concern. Now, what forms the part of the Zero Trust architecture here? So it's the subjects and the data, the users and the data, the services, the devices, and your entire infrastructure. And we will deep dive a little bit into what's the control plane and a data plane, and where does the policy enforcement point sits, where does the PDP, the policy decision point, which comprises of the policy administrator and engine, and there is a trust algorithm, how it's been built. So this is the core of the architecture. So if these things are defined, then you have the architecture defined, and from then on, you can be implementing on phase-wise to your organization. So let's look a little bit in detail about the concepts after the next slide, why we need zero trust. So if you see, actually, right now we are working based on the perimeter-based security, which is not that effective in the evolving enterprise scenarios. And you have cloud data centers, which requires the shared security responsibility when you're going to be using the cloud, which is managed by someone. You have third-party SaaS and PaaS applications, which you cannot, again, trust blindly. The internet network, as I said, is never secure, because in zero trust, you always assume breach. And you cannot verify all the security status of the work from home environments. And you cannot trust the bring your own device, again, which is similar to the work from home. And as we see, the advanced persistent threats are still the tactic which has been used by the adversaries. And day by day, the cybersecurity attacks are increasing, and the stakes are pretty high. And this is why we need zero trust in every step. Now, when you talk about the concepts, there are like 5 concepts, like there is no inherent trust. There are fine-grained rules and policies, inspection and logging before access. So what do we mean by this? The data-centric access control. Now, if you see, excuse me, a computer security model based on a human definition of trust is inherently flawed, okay? So anything that me as a human think like, okay, I'm going to trust this because I have the feeling, and based on that, if I design my computer security model, then that's never going to be 100% right. So hence, there's no one inside or outside the network is trusted unless their identification has been thoroughly checked. An example is like one of the employees has been fired from the organization, and then you have been seeing that person day in and day out. And because the person have not given the ID card, and then after being fired, the person is still coming into the office, you're not going to be doubting anything because you're used to seeing the person. This is the implicit trust, which shall not work in the zero trust. So when you say like, it's the identification and the authentication is verified. So what is the verification process? So there are 3 steps in verification process. So one is the identity, the other one is the context, and the other one is the security part. In identity, you basically do the identification, authentication, and authorization. If you say who you are and where you are from and how do you prove that it is you who are. And when it comes to the context, it talks about the least access privilege. So you get access only to what you need and what is necessary. And when it comes to security, security of the device that you access from. So if you have the anti-malware implemented, or your OS is updated, or the group policies being implemented in your device as per the company's policy. So access is usually not provided based on the location because it's irrelevant, except when involved in the user behavior analytics. So due to the increasing cyber attackers, so inherent trust is an easy way to laterally move within the corporate network, and hence never trust, always verify. So every time something like a user, device, or an application tries to make a new connection attempt, that attempt should be rigorously authenticated and authorized. You shall implement the least privilege. So PAM is a great example of having the privileged access management, and IAM have played a very big role in the zero trust implementations, because you always assume breach. And what do you mean by before access and after verification? So it does not mean that one user got an access to one application, then default gets to another application or within the network. So this is not working that way. So every time when the user wants to access another application, then the whole process starts all over again. When you say data-centric access control, it's a combination of verification, authentication, least privilege, continuous monitoring. You do microsegmentation on the network level, encryption of the data in transit and in use, the data classification, and then the policy control, MFA. So all these things are the data-centric access control, few of the data access control that you can deploy. Now let's see why zero trust is an opportunity to modernize and rebuild. So if you see, off late, when it talked about security, there is a big network transformation going on. So first you had the firewall, then you had the next generation firewall. Then the data center started to move to the cloud. And then earlier you had security and operations independently. Then you had the DevOps, SecOps. So when we say like we modernize the network, so what do we mean by that? So the zero trust actually challenges the idea of a trusted network perimeter as a base. So instead, it focuses on microsegmentation, where networks are divided into smaller, isolated segments. This reduces the attack surface and it limits the lateral movement for potential threats, making the networks more resilient and secure. So we will talk a little bit about the network transformation at the implementation part. When you talk about the cloud transformation, everybody is adopting to the cloud services. So the zero trust ensures that the security travels with the data. So whenever you access data to the cloud, the security have to travel with it. It enforces strict identity verification and access controls for all the cloud resources, hence preventing the unauthorized access and data exposure. But then this approach also supports a seamless and secure transition to the cloud. When we talk about SecOps, I would rather say it's an enhancement than transformation. So zero trust emphasizes continuous monitoring and analytics to detect any anomalies and potential threats in real time. So security teams can proactively respond to security incidents, reducing response times and minimizing damage. But we never say that there is no incident and zero trust is going to completely cover everything and you will never be attacked. We can also talk about the challenges after you implement, where the opportunities of attackers are still might be able to penetrate. And automation also plays a very significant role in the incident response, making the SecOps more efficient. So this is what is about zero trust and why we need it. Let's talk about how do we identify the protect surface. So what is a protect surface? There is an attack surface and there is a protect surface. So the attack surface is your whole environment, your whole IT infrastructure is an attack surface. But if you want to go and protect all of them, it would take years and it would be swallowing all your budget for your whole organization. But then you need to make what is the risk, and we will talk about how do you choose your protect surface. Now, if you see the example, it's a DAS method. We call it as a data, applications, assets, and services. When you talk about data, what data you want to protect. So for example, like healthcare data, where you have the personal information, the medical records of a person. Financial data, it's banking institutions, they must protect the customer account information, account balances, and transaction history. So that's something you need to protect. When it comes to applications, we talk about the e-commerce customer portal. So you need to secure its customer portal where users log in and they make purchases, where they might have their cards registered and access their profiles as well. Data centers, which is housing all the servers, storage, networking equipment, all those needs to be protected. When it comes to services, Active Directory, as an example, because it's a critical service that manages the user authentication and access to resource within the internal network. So it needs robust security measures to prevent unauthorized access or any identification or credential theft. VPN is also another service, because you think like if someone is connected to the VPN, you gets into the network, then you authorize them, which shouldn't be the case. You need to gain the visibility and the contextual awareness about the applications, about the users, about the data encryption, and the files and the data fingerprinting and how it flows and where it goes on. So once you know what the protect surface is, you will be selecting the assets from the big pile of assets that you identified, and then you form a project based on the following. So what is the risk if you don't protect them? And once you choose some applications, is it conflicting with the other programs or other applications? Do you have enough resource to implement this? And do you have enough budget? And then to do that, you also need to have the visibility on all the applications, and which we will soon talk about in the transaction flows, mapping them. You need to understand the network maps. You need to understand the connectivity between the application and the asset users. So we say select high value assets, but it depends on the organization. If you're a huge organization and you're not sure like how to implement it, then you will not start with the high value assets. You will start with the low value asset to understand how the zero trust works. You do kind of a prototype, and then you go to the high value asset. And zero trust is not something like you have done it once and then it's done, and then I'm going to close my box and then I'm going to move on to something. No, it is an iterative process until you, because your environment keeps changing, and then you need to do a discovery of all assets. So I haven't seen any organization which has a complete list of asset inventory. So if you're going to wait for all the asset and inventory is being done, you will never be able to start. So you need to be very agile, and you need to start to do the implementation as and when you see you have a handful of assets that you think like you can start with, and always validate with your business stakeholders, which gives you the upper hand to make security a priority in your organization. Now, having seen how to select the protect surface, let's see that how do we map the transaction flows. So this is a general environment every organization has. So you have a customer logging into their PC, accessing the e-commerce portal through your network, which goes to the web, and there is an application or a web server which is accessing the database which has the PII information. There are IoT devices which connects to your environment. There is an employee connecting to your environment. So why mapping the transaction flow in a zero trust model is a critical step, because you need to understand and secure the data and the resource interactions within the organization. So what does it involve? It involves identifying the various paths and the dependencies that the data, applications, and the users follow as they move through the network. Now, how do you map here? So you need to understand what are identify the key assets and data. So you need to start by identifying your organization's critical assets and data. So again, this will be the same, the databases, application, service, and sensitive information. This is very crucial. And after that, you need to understand the application architecture. You need to document the architecture of your applications, including how they interact with one another and with the users. So you need to identify the components of each application, such as like web servers, application servers, and databases. Why it's important? Because at the next stage in the network level, you will be micro-segmenting them depending on the criticality of these. You need to understand the user roles. So the user roles and permissions within your organization is very important because it determines who needs access to which resources and to what data. So this will be like employees, contractors, third-party vendors, or any other stakeholders who belongs or doesn't belong to your organization directly or indirectly. And then you have the application, you have the device, you have the user role. Now you need to understand how the data flows between this environment. So for each application, trace the flow of data. See how the data moves within or between the applications, and where it is stored, where is it processed and transmitted, because you need to make sure the data is encrypted. So this is how it helps you to identify the potential vulnerabilities and data access points. Because in different methodologies, you need to understand where do you have the decision point and where do you have the enforcement point when you're implementing the zero trust. And you need to identify the trust boundaries, because trust is never assumed in zero trust. So identify the trust boundaries within your network and cloud environments. And there are so many things that happens on the edge of the internet. There is another model called SASE, where the network and security are coming together. So it's very important that you understand the boundaries, because this might exist between different segments of your network, between the on-premise and cloud resources, or even at the network perimeter. You can define the access control policies based on the access controls role-based access. You should specify like who has the access to what resources, under what conditions, and from which devices or locations. So this is going to be your anomalies, and this is how the zero trust is going to depend on whether it should allow you or not. And you implement micro-segmentation. So micro-segmentation is the key concept in zero trust. You need to divide your network into smaller, isolated segments, often referred to as micro-segments. So it limits the communication between the segments to only what's necessary for the business operations. In a big detail, like each of the micro-segment has its own policies. That's also which is defined as the policies. You do a continuous monitoring, and then you also do the least privilege application as part of it. Having seen that how you map the transaction flows, what you need to do is you need to categorize the applications, user, what access, decryption. And then you will always say which are the subjects or the workloads which is known and approved, which is known but unapproved, and you don't know anything about it, it's unknown, and you need to assess the risk of approving it. So this is the basics of how you map the transaction flows. Now you have the protect surface, you have mapped the flow, what you want to do. Now let's go a little bit deeper into the architectural principles. Now you need to know your user. You have a user, and if you see in the middle, you have the policy and you have the enforcement. And SASE is for the cloud, and NG, the firewall, is on the on-prem. And then what are the checks that we will do? Now, here, how do you know your user that you trust the user? The first is the identity verification. You can do it based on a multi-factor authentication. So what does it mean? It requires the user to provide multiple forms of authentication, such as a password, a smart card, a fingerprint scan, or a one-time code from a mobile app with the authenticator. So they have to verify their identity. Once their identity is verified, you need to see the user access policies, the least privilege. So they implement the principle of the least privilege to ensure that users have the only minimum permissions necessary to perform that particular job or the role. So which is the role-based access. So you define the role and assign the permissions based on the job description and job roles. And then you have the user behavior analytics, which are the contextual access controls as well. So you should be knowing like a user behavior analytics tool to monitor user activity in real time. Anomalies or suspicious behavior can trigger alerts for further investigation, because like if someone is accessing one application and from 8 to 4 and then all of a sudden trying to attempt another application in the middle of the night or over a weekend, then it actually triggers that this person is not used to do this, but he or she is doing it. So the contextual information is like the user location, time of the access, the type of the device being used, and hence we call something called as an adaptive access control. So what happens is the adaptive access control, basically it adjusts the access permissions dynamically based on changing circumstances and risk factors. So this is one of the brilliant concept in Zero Trust, but which also makes it easier for the organization to protect and makes it difficult for the attackers to attack. And you can use single sign-on as well, which is again the strength of the IAM solution as well. Now that you know your users, let's see how do you identify your devices, whether this device is authenticated in your environment or not. So you need to have some device identification methods. For example, the MAC address, it's unique for your devices, and your devices have certain certificates. If you have a device inventory, like if you have a inventory that's been maintained for all the devices connected to your network, so it contains the device type, operating system, patch status, who's the owner, who's this device assigned to. And you can also do the device registrations, because once you do register your device within your organization, so it will be having a device profiling. So when you do the device profiling, like the user profiling, it will collect the device attributes, and it assesses their compliance with the security policies of your organization. Endpoint security. So this includes ensuring that devices have updated antivirus software, security patches, and firewall settings as well. And you constantly do a device health check. So to check whether if they detect any vulnerabilities or sign of compromise. So this is also involved by implementing a EDR solution. And you have the authentication process as well for your device, like digital certificates, MAC address, or secure device tokens. And of course, the network segmentation. So you can create a separate network segments for trusted, untrusted guest devices, and then apply the access controls accordingly. Once you know your user, once you know your devices, you need to know the applications. It's similar to the device. You will create an application inventory and all the services running in your environment. So it should include both the on-site data center on-prem, as well as in cloud or SaaS. You need to classify the applications based on their criticality and sensitivity, so that you can put them accordingly in different boxes, and which application, which has a sensitive data, and which is vital to your business. And then you will do the data flow mapping, the application data, where it flows from, and how is it associated with each application, because you need to know how it's processed, transmitted, and you need to identify the application owners. So because these owners are accountable for the security on the compliance of their respective applications. You create the access control policies. So what level of access each user has to such application and under what conditions, and you will deploy the least privilege. You have the authentication and authorization. So based on the role-based, no one will have any access even within the application. If you talk about the SAP, you have different modules and each one of them will have access only to their modules. And you can also have principles to the API accesses. So you have to secure API endpoints and enforce the API security standards. And there are also more about the software development. How do you design? Where do you take the code from? So those things also have to be checked when it comes to your applications. Once you have done, then there is a monitoring part. You will create a baseline. You need to establish a baseline of normal network and user behavior. So this will include the network traffic patterns, user access patterns, and application usage. And once you have the baseline, you will constantly do the continuous user authentication. Every time when you authenticate and authorize the mechanisms to verify the identity of the trustworthiness of users and the device accessing. If you find any changes, then it will block, or if it is genuine, then it will do the adaptive control process. So that is why the user and entity behavior analytics is very important in terms of monitoring, and it does it in real time. You also do the network traffic analysis. So you will use that with some tools to monitor the data flows and then communication between the devices and the applications. You use the EDR and you use the SIM integration, because the security incident and event management tool is going to collect all the logs, and then it's going to give you very good insights on the potential threats if there may be any after these implementation. And then comes the automation part, which is basically using the tools. You get inputs from the threat intelligence, from external, from CDM. So you need to have an assessment and planning. You need to assess your existing security process and identify areas where automation can improve efficiency. So you're not going to just automate blindly everything, because you need to find out what makes sense to automate. So you need to develop a clear plan for automation integration. You need to identify the clear use cases for that. So for example, the common use case would be like user authentication, access control, threat detection, incident response. There are a lot of source solutions. So these can be automated, but there hasn't been nothing for the policy orchestration. There is no real orchestration tool yet, but people are still developing it. So you need to look for solutions that offer you flexibility and the integration capabilities, because still some people have legacy systems, something on cloud, something on your on-prem, and so on. You need to clearly define your zero trust policies for user access, data protection, and network segmentation. You also need to be very clear about the verification process in terms of SSO, role-based access, and MFA. And you need to, every device trust verification must also be made. So when it's a constant monitoring after you implement all these things. Having said this, how does it look in the data and network segmentation? You start with the access control list. So you restrict the data access based on the defined policies. So this should be applied at the, not only at the user level or application level, at the network level, within the applications and at the data layer in your OSI model. And once you have, like, you need to segment, which is called as a micro segmentation. So implement the micro segmentation, but subdividing the network segments into chunks, into smaller segments. On a specific criteria, you can say these applications go here, these users goes here, these data types goes here. You can also, on a higher level, you separate the network zones or virtual LANs and VLANs for different types of assets, which is the current way of doing it. So the ZTNA is a technology when you talk about the zero trust network architecture, where trust is never assumed, and based on location or network segment. Okay, so all the traffic, regardless of its origin, should be treated as untrusted. And of course comes the encryption point of it, where the data in transit between the segmented networks and for data at rest. So you need to have a strong encryption protocols, and you need to have key management practices, how you want to protect them. So if you have all of those things, then you will have an architecture which is completely covered from all the resources point perspective. Now you understand what's the difference between the perimeter security versus the zero trust security. So earlier in perimeter, it's purely location based, external or internal. Anyone inside the network is trusted, and it's based on the different layers. In a particular layer, you had access in an application layer, then you're okay to go through that. But in the zero trust, you never trust, always verify, implement the least privilege, and you always assume breach. If you have known this whole zero trust, this was coined by John Kinderberg while he was in Forrester, and then he moved on to Palo Alto, and now he has played a very big role constantly in zero trust. This is not a new concept. This has been there for almost 13 to 15 years. So what the Jericho Forum Commandments says about the zero trust in 2007 basically is all the devices and applications must communicate using open and secure protocols where you will be encrypting all the data. Now, all devices must be capable of maintaining the security policy on an untrusted network. This is your policies and processes, which is specifically designed for internet. All the people, process, technology must have declared and transparent levels of trust for any transaction to take place. It's a multiple. So this is where your IAMs, your single sign-ons, all this technology which comes through. By default, data must be appropriately secured, classified when stored, transit, and use, where you use the encryption principle. Now, what does NIST 800-207 talks about resource-based? This is resource-based. So there are multiple bays. There are enclave-based. There are multiple deployment models, but I'm taking the simplest so that it's much better to understand. Now, excuse me, when you say the ZTNA, it's the Zero Trust Network Architecture. It's a technology by which the principles of Zero Trust can be used to secure access to the applications and resources. So the core piece of this technology is the trust broker. Now, what is a trust broker? It sits between the user and the application. It continues to verify the identity, the context, and security, the 3 steps of the verification throughout the validity of the session. It's not like the session is done. If the session is provided for 60 minutes, then you're there. No, it constantly checks your behavior. So if the applications are accessed to SASE or on-prem, so in this case, the cloud provider shall be the trust broker itself, if it's on the cloud. For example, you can say Zscaler, Cloudflare, Palo Alto Prisma. But then if it's on the on-prem, then the firewall itself, again, Fortinet or Checkpoint or Palo Alto. So those people will act, those resources would act as a trust broker. Okay, it's not made of a single device. It's made of multiple various technologies, which actually brings in or makes the control and the data plane. Okay, so the control plane, basically it controls the management, the intelligence and the monitor part of it, and the data plane, it does the enforcement, basically the connection between the user and the application. Now think of the control plane as the brains or the decision maker of the network. So it's responsible for making high-level decisions about how data should flow within the network, like determining the best route for the data to travel from one point to another. The control plane is the one which sets the rules, policies, and instructions for the network devices like routers and switches on how to handle the data traffic. So if you, in simple terms, if you want to understand, the control plane decides where the data should go, how it should get there. You can imagine it as a traffic cop at an intersection, directing the vehicles which way to turn and when to stop or go. On the other hand, the data plane is where the actual data traffic flows. So it's like the worker of the network that follows the instructions given by the control plane. So when the data packets or the chunks of information need to be sent from one device to another, the data plane handles the actual movements of these packets following the rules set by the control plane. So if you want to put it simply, if the control plane is a traffic cop making the decisions, the data plane is the vehicles on the road actually driving and following those decisions. So the control plane is responsible for deciding how data should move within a network, while the data plane is responsible for physically moving the data based on those decisions. So together, they ensure that the data flows efficiently. Now, there are multiple places where you can place the decision point, and there are multiple places like where you can put the PEP in an organization. But what would be the difficulty here is wherever the PDP, the policy decision point is there, if that particular environment, if that firewall, if that infrastructure is hacked, then the hacker can change the policies and you wouldn't know if you didn't find out that that particular thing is breached, okay? And then the concept to deploy in a legacy application is pretty much difficult. And usually the management and the business users do not agree and accept to change in an organization. So those are a certain amounts of cons, what happens in this kind of a model. So as a recap, if you see, this is what is zero trust architecture is about. You just need to remember, like, you have one of the methodologies is software defined networks. You call it as a software defined perimeter, SDP. You do a constant and continuous verification. You give the least access privilege. You don't rely on the perimeter security. You do the microsegmentation, adaptive controls, identity based, machine learning for automation. And end of the day, you never trust and you also always verify. If you see a simple implementation, this is from one of the Microsoft way of implementing. So on the left, you can see a zero trust, which is a basic model, how you can implement. For identity, you have something for strong authentication. You do federation with the cloud apps. For the devices, you can use the MDM or endpoint protection or EDR. For data, you use the auto discovery, like you have the Azure information protection or Symantec DLP solution. In an optimal way, you go to towards the single sign-on. In infrastructure, you give JIT, which is the just-in-time access, and monitoring the abnormal behavior, the user behavior. In terms of network, you give isolated access, you monitor the traffic, you encrypt all the traffic. So there are like basic, optimal, and recommended. There are different types of implementation that suits your requirement, okay? And where do we come? We can help you we can help you with this technical business discovery part, technical and business discovery part for your organization. And then we can define the architecture and the strategy that suits depending on your timeline, optimize the architecture that you currently have. So that is a short term. On a longer term, like we said, there is no end to the zero trust. You keep continuous monitoring and maintenance, and you continue to enhance as and when the technology changes, right? And now, as a recap, so you define the protect surface on those 4 areas, and then you map the transaction flows. And now, what is a Kipling method? This is very interesting. The Kipling method, it's an approach to implementing the zero trust security model. If you have heard about the poet Rudyard Kipling, he had a poem called The Elephant's Child. So it begins with the phrase, I keep 6 honest serving men. So that's why you see the 6 here, the 5 W's and 1 H. So in this context of zero trust, what it does is it provides a straightforward framework to guide organizations. So the who needs access to what, when does they need the access, where the access is required to, and why. And then how it is being provided. So based on these things, the action is whether to allow or block or implement MFA or do something in between. Again, so what does it summarize after all these things is you verify the users and devices, you do the least privileged access, microsegmentation, detailed logging and monitoring, you do the encryption, and you always assume breach. So the Kipling method, it provides a clear and a memorable framework for organizations to implement the foundational principles of zero trust in a very straightforward, in actionable manner. So every time when you take when you use the 5 W's and 1 H, you will definitely have an answer for every question you have, whether you need to implement zero trust or not. And now what are the benefits? I think by now you would have known it's a repeatable and predictable security strategy, which means you're always aware that what's going to happen. So at least you can foresee and you don't have to be reactive, you can be proactive. And you have the higher confidence and consistency in your security controls. Your operations will be simplified through automation because you don't have to manually keep checking and verifying on every 3 months through an audit. And then significant risk reduction with the fewer breaches. So we don't say there's no breach, still the adversaries are much, much advanced than where we are. I'm not taking any particular case study, but it's a combination of, on the left, you can see which is the SASE, and on the right, you see the on-premises, and how from both for retail or supply chain, for multi-cloud, for remote users, whatever your environment is, how is it connected to the zero trust, which is in the middle, and whether you are on-prem and then through the firewall, how is it connected? So I don't want to go deep into the SASE, but SASE is the Secure Access Service Edge, which was coined by Gartner, which combines the multiple network and security technologies into a single offering. In SASE, there are 3 types. One is the core, the other one is recommended, and the third one is optional or Optima, we can say. So the core, you have the SD-WAN, secure web gateway, firewall as a service, CASB, and zero trust network access, the ZTNA, which falls into the core of the SASE concept. And for the recommended, it's like sandboxing, browser isolation, web application firewall, NAC, antivirus, or EDR. And when it comes to the optional, it's the older version of wide LAN and VPN. Okay, so if you see on the left, on the retail branches, like it's connected through the SD-WAN and MPLS, supply chain coming through VPN to SASE, the web proxies used for the multi-cloud, for remote users use the VPN. On the other hand, everything is connected to the NGF, the firewall, next generation firewall. And then it comes to the zero trust, where you have the single policy, which is authenticated, user ID, app ID, device, and the content, and then all the methodologies and all the technologies that is used, so which will do the continuous trust verification. And these are some of the vendors who are kind of pioneering and who are kind of in the market. And this is just for you to understand if you use any of them or if you would be interested in any of them. So we are vendor agnostic, so I'm not promoting specifically anyone here, but then these are the trends over there. And this is something I did in 2015 because of getting some adrenaline rush. And I thought this is very apt to put this picture here when I was jumping from the plane 4,000 meters, trusting some random guy who's going to bring me on land and I'm going to be in one piece. So this is something like, it's a zero trust. So I had to verify, I had to see how many jumps he had made. And before I jumped, I saw him jumping with 4 of my other friends, and I saw how he packed the parachute, how he opens. So I had to go through this. So I verified completely before I trusted him. And I'm still here, which means my zero trust concept kind of worked. So this is a strategy, once again, that recognizes the importance of verifying every attempt and ensures the higher level of security for your organization, valuable assets. So we are at the end of the session, and I hope I wasn't too fast. So there's a couple of questions which Subin might take over later after the session if you want to discuss something. And thank you for your attention, and thank you for this opportunity. I hope you had some insights about the zero trust and what you want to do for your organization. Thank you.